Hello guys, so we shifted to another topic and coming back quickly, as quick as the speed of light, 3 times 10 to the 8 meter per second, the speed of light in a vacuum, in the theory of relativity discovered by Albert Einstein, where E is equals to mc squared. E stands for the energy, and n, the mass of an object, times the c, the velocity and the speed of light. Okay, that's only a very pure science introduction. So let's go back to our main topic for today. Let's talk about monoatomic and polyatomic ions. I put ions because general. So, but don't be wondering why that, I will be stressing a lot of anions somewhere along the way. So, in order to include also the positive charge or positive ions, then I will just put in my title ions, general. Okay? You get the point? Things like that. And now we go to monoatomic. First, monoatomic examples. Monoatomic ions or anions. Okay? So say ions also, right? Monoatomic ions. Okay. Number 1, examples. So we have fluoride. Okay. -1. Chloride. -1. Bromine. -1. Okay. Iodide. -1. Oxide. -2. Okay, that's the point mga palagingging. Okay. That's gonna be like that. Okay, peroxide. -2. Okay, you get the point. And superoxide. Okay, O2 -1. Okay, you get the point. Superoxide. Okay, correct if I'm wrong for the superoxide. 0, -1. Okay, that's correct. Okay? Because if we try to compute the oxidation number, so 2x, 2 times x is equals to -1, then x is equals to -1/2. Because the oxidation state of, okay, peroxide, superperoxide is, okay, -1/2. Oxidation state. That's where the charge is -1. See here. It looks like a little bit complicated, right? Okay. So we need to say, the oxidation state and oxidation number is not equal with the charge. Okay? So we have also, another thing is nitride. Okay? 3, negative. Nitride, exponent 3, negative. Okay? Then, N3, -1. This is not nitride. This is azide. Okay, as explained a while ago. You get the point. Sulfide. Okay, 2, negative. Okay. Fluoride, 2, negative. Like that. Phosphide, 3, negative. Okay. So, put that in your brain cells that nitride and phosphide have the same, okay, and ions at the top 3, -3 charge. Okay? Because it will confuse you with sulfide somewhere along the way. You get the point? Anak siya. Okay, then hydrogen. Hydrogen is also positive, and it also takes a dual charge. H negative. H negative is hydride. Okay. Follow the pattern of fluoride, chloride, bromide, iodide, which has a charge of -1. So hydrogen also is possible, hydride. And we have also the positive charge of hydrogen. Okay, the original. You got the point? So H positive and H -1 will be okay. Okay. Anything else for the monoatomic ions? It's always like that. This is the whole package. I think of another, let's say, nitrogen. It's here, see? Nitride. Get the point? There's nothing. Add some more if you want to suggest. Okay. There are at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, get the point of your monoatomic ions. Get the point? Okay. Number 2, polyatomic ions. So many. Okay. So we'll start with a positive. Ammonium NH4 positive. Hydronium ion H3O positive. You get the point? Now, by the way, I forgot the ozone. What is the charge of an ozone? O3. O3 is the chemical formula of the ozone layer of the sun. The sunlight, that is O3, ozone layer. So, it's negative 2 again also. Okay? So, let's put also the ozone, right? Ozone, O3. Okay. O2 is very easy. No need to be worried for that. But still negative 2. Okay? Like that. Okay. Now for polyatomic anions or ions, NH4 positive, H2O positive. Okay, like that. So, I need to emphasize this hydride. That's why we have also say sodium anhydride. Things like that. Okay? Meaning to say, it's not hydrated because there's a word an. There's no water. Okay, when we mean of anhydride, there's no water. If there's hydride, there's water. Okay, or we say hydrate. Okay, it depends on the chemical formula you're using. If you use the negative in terms of this only, it's hydride. It's a polyatomic and ion, it's hydrate. You get the point? Things like the anak siya. Okay. Dehydrate water na siya times 4 water. For example, you have, let's say, gypsum. Gypsum, the chemical formula of gypsum is calcium sulfate times 2 moles of water. Your 2 moles of water there will be your hydrate form attached to calcium sulfate. So this is the hydrated form of calcium sulfate is the gypsum. Only an example, there's a lot. Okay, you get the point. Okay, so going back to polyatomic ions. Okay, now we have your favorite, right? So let's say there's so many things here to consider in this fourth thing, halogens. But let's try only the representative. Let's say let's try the fluoride. Okay, because it would be the same pattern by using. So let's say fluoride. F. Okay, FO. Right? Fluoride na akong gibutang dala, guys. F. Okay, fluoride. So meaning to say FO3 negative. Looks like strange, right? Because we always use chlorate, bromate, and iodate. So, oh my gosh. So this sounds strange. See? Because to be honest with you, fluoride is not always used most of the times, but to follow the pattern. So FO3 negative fluoride. Okay. Fluoride. FO2 negative. Okay. Hypofluorite. Okay. FO negative. Perfluorate. Okay. FO4 negative. Okay. So you have now the ATE. Okay. ITE. Here. ITE. And ATE. Note the difference. When you say ATE, it's more than 2 the subscript of oxygen. Okay, sir. Perfluorate. ATE here. Fluoride. Now, if you use ITE, maximum of 2 subscript from 1 to 2. ITE is a hypofluorite. Hypofluorite. hypochlorite. So if there's no subscript, that would mean hypo. But you pair that with ITE. Here, ITE again, because I said maximum of 2, but there's no hypo in the term. That's why only fluoride. So memorize the whole package and apply that to chloride, bromide, iodide. Also the same thing, okay, for the purpose of discussion. Chlorate, chloride, hypochlorite, perchlorate. Okay, bromide. Okay, bromate, bromide, hypobromite, perbromate, iodide. Okay, iodate, iodide, hypoiodide, and then periodate. So when you use per as your prefix, you need to put 4 subscript in oxygen. Okay? This is subscript written at the bottom. This one. Kailangan mag-moles. You got the point? So subscript. Okay. So pair. Okay? Things like that, no? And the rest will follow, I think so, yeah. Penta. I think there's no penta. Myron. Pentawate, heptawate, hexawate. Like that. If this is FO5, FO6, FO7, FO8, FO9, FO10. Until 12 atoms of oxygen subscript, it will become dudate, fluoridudiate. Okay, you follow the pattern of Ayupa chemistry in bingo, so you can follow that one. If you know the sequencing of the, prefixes, then perfect. Okay, but if you don't know nga, you got the point, things like that. Okay, so this is gonna be, and go to the sulfate thing. Okay, what do you mean by sulfate thing? Okay, so you are now having the sulfate, no? So, sulfate, SO4 negative 2, sulfite negative 2. In here, it's not the same, because you will never say pair sulfate because there's 4 here. Why? Because SO is a total package originally. If an O is not a total package, you are only combining one element to another element to become FO. But here, sulfate is really a total package in saying that salt. Originally, you cannot isolate that. Okay? Things like that. You will isolate that later. But this one is, you add only fluoride and oxygen. So this is not the original version. That's why you need to put pair this 4. Okay? It's not the same, right? This is not pair sulfate. And this is pair, okay, perfluoride. Number 4, ano man ito ipariha? Okay? Because SO4 is a whole package thing. And this one is more on individualistic category. Or individualism. And then you add only. You got the point? That's the rule in chemistry. Okay, so sulfate negative 2. Sulfite negative 2. Okay? Sulfite, sulfate. Okay. Now, if I will add hydrogen here. No, hydrogen sulfate. What is your charge? Hydrogen sulfate. What is your charge? So your charge of sulfate is negative 2 and your charge of hydrogen is positive 1. Minus 2 plus 1 is still negative. So this is H is O4 negative 1. That is your hydrogen sulfate or bisulfate. Okay, hydrogen sulfate. So this is the case where we say bisulfate. Okay, this is the category in which the sodium bicarbonate belongs. Okay, that's the point because of the bi thing, negative 1 charge. Let's go later to there. Okay, so hydrogen sulfate or bisulfate. Now, this one, carrying is all 3. So HSO3. Okay, this is hydrogen sulfide. Bisulfite, and then the charge will be negative 1. Okay, hydrogen sulfide. Okay, mga palagingging. Okay, and bisulfite. Okay, like that. Put that in your brain cells that ITE is always lesser in subtract compared to your ATE, the ATE and the ITE. You get the point? Ganon. In analogous with your elements also, if the charge is positive 2, it will be, for example, coprous, copric, like that. Copper 2, copper 3. Things like, example only for the purpose of discussion, but I think that's the true charge. 2 and 3 also, right? Copric and coprous. We have also the gold, auric and aurus. Okay, the gold. Okay, things like that. So we have HSO3 -1, right? It's gonna be like that. Okay, so many things, no? And let's go to phosphate, mga kapatid. Okay, so the individual monoatomic is phosphate -3. Okay, take note, -3 ang charge. Okay, like that. Now, if you let's go back to the hydrogen sulfate. If you put 2 subscript in the hydrogen, it will now become a sulfuric acid. H2SO4. So meaning to say, sulfuric acid is also known as dihydrogen sulfate. Okay? To be strict. Okay? Why I can say that? Because oxygen, sulfur, hydrogen are all non-metals. You can apply the naming of numbering like tetro, penta, hexa, like that, or pent. You can apply that terminology in all non-metals only. You cannot apply that in metals. You get the point? That's the rule. You never say, for example, I will say iron 3 chloride. Okay, iron 3 chloride. I will never say monoiron trichloride. Because the IUPAC chemistry says in the rule, you cannot apply that in a compound that is highly metallic in character. You get the point? And then, even though the chloride is bonded, but still it's not. Okay, you get the point? You will never do that unless it is always like this, all non-metals. Or the molecular covalent compounds. Tama ba? Molecular covalent compounds. Yes, like the hydrocarbons. Propane, like that. Okay, gata po, mga pwede niyo basahan o mga inana. Okay, gata po, sa mga bi, like that. Okay, there's a rule for that, ha? Okay, now, phosphate. Okay, so phosphate, mga palagingging. So, PO4 -3. Okay, the version of this. Okay, hydrogen phosphate. What is the charge for this? -3 minus 1, -2. So, the hydrogen phosphate, it's not biphosphate. Why? Because the charge is -2, even though the hydrogen subscript is only 1. You can only say bi-2vas, okay, when your subscript of hydrogen is 1 and your charge also is -1. Just like bicarbonate, HCO3 negative. Hydrogen subscript is 1 and then the negative charge, the net charge. Here you cannot say because it's -2. You will never say biphosphate here. You will say only hydrogen phosphate. So meaning to say, the naming of bi-2vas or bi is limited only up to sulfate. You cannot apply to phosphate. So that's why in chemistry or in science, you never use patterning. As I told you over and over again. There's really rule. In math, there's pattern. That's 2, 4, 6, 8, even numbers, add numbers. But in chemistry, it's not. Because if you try to pattern this one, why this is not biphosphate? Okay, the same thing what we did with hydrogen sulfate. Right? So, you will be wrong if you keep on patterning in studying chemistry. This is not a pattern. You get the point? It's really a rule. And to apply the analysis, where can you say it's like that, and also some exemptions to follow. That's why concepts are very, very important in pure science and in chemistry, or whatever pure science. Okay, get the point? Things like that. It's not really logic only, or puzzle. You get the point? Just like in FB, puzzle. Okay, because you have so many interpretations in the puzzle. Logic question, and you can create so many answers. And the author will only choose the answer what's best in his mind. And if you answer the other possible answer there, that it's still okay, then it will be wrong. Okay? So, muratag, nagduwa, kita rin himong buang. Logic. Kung ang anak mo, so it's not, it's opinionated. You get the point? Things like that. So, muna siya nga, that kind of lag is really a crap. It will not increase it will not sharpen our brain cells. That kind of logic, that does not have specific answer to follow, so that's not good. Get the point? Sa math, puzzle, it would be okay because it's really pattern like the PEMDAS rule in chemistry, and have chicken, flour, like that. So what is the answer? So it's in math, PEMDAS rule. Okay? Start first with parentheses, exponent, multiplication, addition, and subtraction. So it's specific. If you rumble that operation, you will be wrong. So if you put so many numbers there, and there's a lot of operations involved in one sequence, okay? Then if you use addition first in your solving, you will be wrong because the rule in math says, okay, PEMDAS, and you do the subtraction first because you feel comfortable. So you will be wrong. Okay, even if the addition will be in the first. Okay, you will say 2 plus 3 times 6 plus 2. And then since the plus is in the beginning, you will do it first. No, it's not. Because PEMDAS, what starts first? PEM. There's a multiplication first. The multiplication is in the second. Okay? So you will start with the 6, not on the 2 and 3. So you will be wrong. Because you did not follow the rule. Okay? By only logic, chuvas. Okay? It's not. Logic will not work all the time because that's opinionated. Too much opinions. Okay, things like that. Kung asawa mo, sino ang asawa mo? That's only fabricated, you know? That's not good. Okay. So we have HPO4 negative 2. So it's our hydrogen phosphate. Now, our hydrogen phosphate. So, HPO3 negative 2 also. Right? Ganon. Our phosphate. PO3 negative 3. Okay. PO3 negative 3 is the phosphate. Now, how about, sir, the borate? Okay. Guys, there's no boride, ha? But there's borate. Borate is BO3 negative 3. This is coming from the boron. Okay, boron, right? I think boron has an atomic mass of 10.18 grams per atom. Boron. Okay, things like that. So, borate, BO3 negative 3. It looks like in parallelism with the form of the phosphite, no? But take note, the way you will say it's not the same. Here, borate, ATE. Okay, but here, phosphite, ITE, but the same, negative 3 and charge also of oxygen 3. That's why this is there's no pattern. Okay, you get the point? Things like that. Again, BO3 negative 3 and PO3 negative 3, the same form. Right? Oxygen 3, subscript, oxygen 3, subscript, charge negative 3. Then why you'll never say this also boride? This one. Because this is phosphite. Okay, that is borate. Because in the borate chuva or in the borate context, there's no boride. There's no hypoboride. Only borate exclusive for the boron. Special treatment. Again, in a boron chuvas packaging, only borate, no boride, hypoboride, like that. Okay, there's no perborate and everything. Only borate. Kanila gyud siya sa boron. BO3 negative 3. You get the point? Exclusive. So don't fabricate your own if it does not belong to the rules. You get the point? Things like that. How many now? 1, 2, 3, 4, 5. So there's a lot. And now we go to the sulfur specialties of this sulfur. We have also sulfur specialties, polyatomic and ions. And you need to remember this, ha? Di ba mga palaging? Okay, yes. Okay, thiosulfate, H2O3 negative 2. That's thiol. Okay. So just memorize plainly because there's no basis at all. Well, you say that as long as we know, when we know thio, you incorporate sulfur. That's the main thing. Thio means adding sulfur. Okay. Okay. That's very clear. Okay. Now what else for sulfur? H2O7 negative 2. This is pyrosulfate. Okay, this is special cases that there's no basis to say. It's only memorization. You get the point? Things like that. So, thiosulfate and pyrosulfate. Okay. Nakuha na? Okay. Now for our phosphorus also, we have the version of the pyrothane. We have the pyrophosphate, P2O7 negative 4. The only difference between the pyrophosphate and the pyrosulfate is the charge, negative 4. Always bear in mind that phosphorus have a greater charge always. Okay? So in case of pyrophosphate, negative 4, but the same, P2O7. What I mean by the same? The same subscripts. Because pyrosulfate, though the charge is negative 2, but the subscripts are the same. S2, 2, and O7 also. Get the point? So pyrosulfate and pyrophosphate and thiosulfate. Now, how about cyanide? Cyanide is used as an explosive in dynamite fishing, right? Like that, and then the fish will die. Okay, because cyanide is highly explosive. Okay, cyanide is negative 1. Okay, so in the monoatomic. Now, if you put that in the polyatomic, it will become SCN negative. This is thiocyanate. As I told you, you put thio if there's an addition of sulfur, and then you have the only difference is that you change to ATE. Okay, and this is also special because when you take note the rules. It's not really patterned all the time perfectly. See, ATE, but there's no subscript. In fact, there's no 2, there's no 3. Why using ATE directly? See? So that's why you need to understand and coupled with comprehensive memorization. If not, mungangajud ka in chemistry. You got the point? Things like that. You will be wondering why the rules doesn't follow everything. Okay, so see, ATE, and there's no subscript. So I will say it's supposedly thiohypocyanide, but it's not. It's thiocyanate only. You get the point? Okay, SCN negative. Okay. Ganon siya, no? Mga palangga kong hintad. What is the atomic mass of cyanide? 112.4 grams per atom. Okay. Things like that. Now, another thing also. For nitrates chuvas, no? Ano ito sa mga nitrates chuvas? Okay. First, NO3 negative 1. Nitrate. NO2 negative 1. Nitrite. But there's no hypo thing. Hypo rule is only applied for halogens family. Fluorine, chlorine, bromine, iodine. You will never apply that to any other else. You will say, hypo because you put also H here. Charos. And you will see also binitrite because H NO2 negative. And you will say, binitrate also that one. Because there's negative one and there's one subscription, binitrate. So it will not be applied. It's not pattern. Okay? It's not patterning. You get the point? So things like that. So, dili bawal dito mag-pattern every time, ha? In science. Okay. Things like that. So, this is nitrite. Okay. Nitrate. Nitrate. There's no hyponitrite. Take note. Okay. Now, nitrate. Ako nang i-mention area nitrate. Mention na. Now, we go to this NO4 negative 1. What's this? NO4 negative 1. So imagine we are already having the ATE here as nitrate. So here, what's this? Obviously, okay, pair nitrate. Because 4, pair nitrate, or the other version to call this is peroxynitrate. Okay, peroxynitrate. If the subscript of oxygen is 4, again, you will be tempted to say also, no, nitrogen tetroxide. Right? Nitrogen tetroxide. But there's a charge. It's a polyatomic and you can never say that one. Because 4 is tetra or tetro. It depends on the words you are following. Okay? If it's oxide, that's why tetro, like tetroxide. So it's not good to listen. That's why tetro. But in terms of CCl4, this is carbon tetrachloride. Okay? You get the point? Here tetro, here tetra. But the same thing. Okay? So here you can never say nitrogen tetroxide or mononitrogen tetroxide. No, it's not. Because there's charge. Okay? So this is pernitrate and peroxynitrate. Ganon. Now, what if having NO4 negative 3? Hala? Nari na sir 3. Yes. This nitrogen stalls the ability of the phosphorus charge. Phosphate. Hindi mo siyang 3. So this gonna be orthonitrate. The ortho thing is like, that is not the original charges, but they steal from the other polyatomic anions, because negative 3 is usually the charge of phosphate. They offer negative 3. And nitrogen is always negative 1. Then, he really borrowed the charge of phosphate. So that's why ortho, special case, orthonitrate. You get the point, things like that. Okay. So we have now nitrate, nitrite, pernitrogen peroxynitrate, and orthonitrate. Okay, get the point? Things like that. Okay. Now we go to kalas na ba? There's a lot, right? Okay, meron pa siya. Okay, chromate. Okay, chromate. So, chromate, I will tell you something when I was in college. Chromate, CrO4 negative 2. Guys, in my college days, I always mixed up with Cr2O4 in this memorization. I always became wrong in this because it's always 2. But chromate has no 2. This is my reason already until now. Because I always mix up with this formula. Okay? It's not Cr2O4. It's in the version of oxalate. Okay? I think I was mixed up so many times for this. Chromate has no 2 really. Okay? And then dichromate have 2 na. Cr2O7 negative 2. Okay. C2O4 negative 2 oxalate. Okay. C2O4 negative 2 oxalate. Now, if you try to put that in organic chemistry, how can you say that? Oxalate. So, carbon. No, so carbon. Then you have oxygen. Then oxygen. And oxygen here. Okay. Then another carbon here. Right? Carbon. Okay? Here. oxygen, and oxygen. How many oxygen? 1, 2, 3, 4, 1, 2. Okay, like this. Okay. So this will be negative here and negative here. This is the structural formula of your, okay, oxalate. This one. First time. I just interpret now without using any reference. Because you can understand, but it's for, there are so many things in chemistry that even though you will not study, you will not really encounter that. You can make your own because you understand really what's the rules. Just like this, first time in my entire life that I created the structural formula of oxalate. This one, in an organic version. I never do this in my entire years in my college. Just now, on the spot. This one, see? I just analyzed this. There's 2 carbon and there's 4 oxygen. Okay, then remember the octet rule. 4 electrons shared in the outermost shells of the carbon. So, hindi ko magpataka o butang mga electron shared because I know the rules of octet rule. Right? So, on the valence electrons of carbon, then you put oxygen. We know I have 4 oxygen. So, 1, 2, 3, 4. So, if it is balanced perfectly, so that's it. I created my own. This is also found in the books, but I don't refer the books because I understand already how it is being structured. You get the point? Things like that. So, muna siya yung mga technique. You need to understand really the, you know, the rules. Okay? So, namin yung mga ATE sa organic chemistry, there's a negative thing on the oxygen. Like that. Like, glycerate. Oh, this negative also. Okay. Ganon. Di ba nakakaloka mga kapatid kong hitan mo? Okay, anak siya. Okay. So, muna siya ang glycerate. C, ganon chupa-chucho, CH2H, OH, H, din siya, O. Hindi na siya, O na lang na siya. Instead of OH. Nahawa ako sa H, nahimo siyang negative. Wala nag-differentiate sa glycerate. Okay. So, let's say aspartate, glycerate, acetate, okay, lactate. Muna siya ang mga anak. Then if you go to acid, nahimo siyang lactic acid, glyceric acid, like that, okay? So, muna technique, phosphoric acid, phosphate, imo sa iko ng phosphate, ano po na siya, ang version. Okay, you get the point? We take account ang mga element of how many valence electrons in the outermost shell, then perfect. Get the point? Things like that. Okay, what else? Manataan sa mga diachromates, tubo sa late. Okay, now we go to permanganate. Okay, permanganate. So what's the difference between manganate and permanganate? Permanganate is NNO4 negative 1. Manganate is MnO4 negative 2. Only the charge. Meaning, permanganate is higher than manganate because negative sign is always higher in small number than in big number. If I have negative 4 and negative 6, which is higher? It's negative 4. So the same thing, negative 1 and negative 2. That's why I say, permanganate is higher than the manganate. You get the point? So math also will apply. You get the point? Things like that. Okay. Now if you determine the oxidation state, so very easy. Okay. So you will say, X plus 4 times negative 2 is equals to negative 1. So X negative 8 is equals to negative 1. X equals to negative 1 plus 8. X is equals to 7. We have oxidation state of positive 7 here in the permanganate. So obviously, ito ba siya, i-increase naman siya sa positive 8. No need to do again the algebraic expression of computing the oxidation state and oxidation number. You get the point? Ganon. Okay. Diba guys? If I will say, dihydrogen, for example, mag-create ko mga ako dihydrogen, dihydrogen, okay, let's say, sulfate. What is the formula, chemical formula? Dihydrogen sulfate. Dihydrogen sulfate is simply the sulfuric acid, H2SO4. Okay? So this is another name of dihydrogen sulfate. So if I will say dihydrogen sulfide, oh, that will be H2S. Okay, H2S. Some also will say hydrogen sulfide. Some also will say dihydrogen sulfide. Now, which is correct for these two? Which is correct for these two? Okay, this is both correct. Okay, you can use hydrogen sulfide, you can also use dihydrogen sulfide. The hydrogen sulfide is only more precise compared to hydrogen sulfide. We understand because this two is coming from sulfur, it's not an issue, it's not coming from hydrogen, the charge. So it's okay to say hydrogen sulfide and dihydrogen sulfide is just equal. It's just the same. Okay, like that. But why here, in the case of dihydrogen sulfate, is not equal? Because the charge will exceed -1 during the subtraction of each charge. So see, -2 here, and then here is only 1, like that. So it's not applicable here in the other story here, huh? Okay, H2S. Okay, I can never say hydrogen sulfate because the moment I will say hydrogen sulfate, it will become HSO4, right? And -1. So this is hydrogen sulfate. Okay, this is not dihydrogen sulfate. The hydrogen sulfate in here is the sulfuric acid, but it's not true in the H2S. Even though there's two, you can say also hydrogen sulfide and dihydrogen sulfide because you know this is monoatomic anion, the sulfide. Okay, it will matters a lot sa iyang compound. Nakakaloka. Did my question so far for that? Okay. So that's why we are opted to use the most easy to recall. What do you mean by most easy to recall, Sir Sotero? For example, sulfuric acid is very easy to recall. We are not using all the time dihydrogen sulfate, right? Okay, it's not comfortable to say. Okay, but in the examination in the future, the usual question will be, what is another name? What is another name of sulfuric acid? A. Hydrogen sulfate. B. Trihydrogen sulfate. Kung ganun siya ba, no? Hydrogen sulfate, dihydrogen sulfate. So you can analyze that and you can get it correctly. You get the point, things like that. So HCl. HCl is also hydrogen chloride. Okay? Hydrogen chloride or hydrochloric acid are just the same in saying. You get the point? Ganon. Okay, any questions so far? So, natasaan yung mga manganate, permanganate. What else, guys? I think nahulot na. Okay. I explained everything about the charges. Okay, or not yet, guys? Tell me. So, what else? Okay. You see, hydrobromate. Hala, hydrobromate. Say like this. Hydrobromate. Is this okay to say or not? Hydrobromate. Is this okay to say? So you will say HClO3, hydrobromate. Okay, because this is -1. Okay. This is not hydrobromate, it is hydrogen bromate. Okay, hydrogen bromate. You got the point? Okay, -1 kasi mawala yung charge, so 0. Okay, so wala siya charge. So wala siya yung existent, ganun siya. So it exists as a compound, not a polyatomic anion. Okay, see? -1 ang chlorate. +1 ang hydrogen. +1 plus -1 is equals to 0. So you don't have charge in hydrogen chlorate. But it's not hydrochlorate. It's hydrogen chlorate. Okay? You will say the whole thing. Kanang hydro abbreviation or mabula, guys? Okay. Is that the point? Abbreviation pa sa hydrogen. Unang hydro. Hydro testing. Hydrostatic pressure testing. Iputol na ang hydrostatic into hydro. Hydro testing. This means completely hydrostatic. Hydrostatic pressure testing. Okay, this is not only hydro, it's only cut only. You get the point? It's abbreviated to something. That's why when we are in our family, in our home, we don't need to say always abbreviation. We need to emphasize really the whole word so that they can understand when they grow up. That's gonna be the complete terminology. We will not entrust always to the teachers, to the school that's the time they will learn. You will learn best in the home, not on the school. Okay? Because you are really the front act of your children. What's the basic unit of the society? So as a parent, then you need to teach and educate them the right thing to do. Okay, things like that. There's no abbreviation like this. Okay, so hydro means hydrostatic. Ganon. Okay, get the point. It's a combination for something. Okay, get the point. Okay, guys. Okay. So very clear sa itong mga monoatomic ions and polyatomic ions. So master na to ang mga redox balancing equations. Charis. Okay. So for example, if I have, let's say, okay, phosphoric acid. Phosphoric acid. So H3PO4. Okay. Then, if you try to dissociate this into water, let's say an aqueous solution, it will become aqueous, right? So, what will be your dissociation products for this? Di ba? So, this will become H2O plus phosphate negative 3. Okay, like that. You get the point? Since you are taking away the H plus of water, so H plus. So H plus plus PO4 negative, so it will become H3PO4 because you interchange the charge between the two. The charge of hydrogen will go to the phosphate and the charge of phosphate will go to the hydrogen, so H3PO4. So during dissociation and ionization in water, you need to take only the H ion according to Arrhenius theory of acidity and basicity. H ions, positive, like that. Okay, but the correct is this one. But this one is not yet balanced. You have to balance also that later on. It's not balanced. Okay, you get the point? So this purpose of illustration. But don't be tempted to do like this. H3PO4, you will say 3H plus. Get the point? And they will say 4PO. You will never alter the phosphate because this 4 is the whole package of phosphate, the original thing. So you don't do this like this, huh? Get the point? Because a lot of ionic equations follow also like this. So you need to understand where to draw the line during your calculation. Okay? If kani siya, patterning mo na siya. I-patterning mo siya because most of the ionic equations, the subscript will become at the coefficient of the whole compound. But phosphate is the whole thing. PO4 talaga siya, originally. And so you cannot put the 4 beside the P or as a coefficient. The 3H is okay because originally hydrogen is only H. And so you can put the 3 beside hydrogen. Get the point? Ganon. Okay, just like OH, you will say 2OH, 3AH, 4H. Why? Because OH, the original package, there's no subscript. OH alone, the negative 1. So you can put the 2 beside, 3 beside, 4 beside. But in the phosphate, it's not, right? Okay, things like that. Ganon. But for getting the oxidation number, you have to do that. See? Yung kuha ito na H3PO4. Okay? In getting the oxidation number, is it 3 times H plus 4 times PO. Oh, is equals to the charge 0. 3 hydrogen plus 4P plus 4O is equals to 0. Then substitute all the charges. Phosphorus, oxygen, you can get the H, or either way around, substitute the hydrogen. If P is given, unknown, you can convert to P, ganun siya. Okay? Things like that. Diba? Kung 3 elements na ang mag-mix dira-ara, something is unknown there in your oxidation and reduction. Or else, if you know everything, then there's no use for the reduction there. Because if you try to be strict, you know already negative 2. The phosphorus also, you know also, right? It's gonna be negative 3. Sa phosphide, diba? Negative 3. Okay. And then sa hydrogen, positive 1. Then why you will keep on computing one by one if you know already? Because that's the purpose of reduction and oxidation. At least one of them will be unknown in oxidation state. So you cannot say who among is gaining electrons or losing electrons like that. That's the case. Right? Ganon. Okay. Nakakaloka. Okay. So ang phosphorus 5 ba yan guys yung valence electrons in the outermost shell. So let's draw now the H3PO4 no. So ano ba? Ano din na mo ay wala? Okay, so P. Diba P? 1, 2, 3, 4, 5. That means yung habil 5 pa na ang phosphorus. No? Ano na? Okay. So, gonna be double bond. Oxygen, 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 oxygen. Ano no? Tanawa. 1, 2, 3, 4, 5. 5 valence electrons in the outermost shell of phosphorus. Okay, ganon. So that is PO4 3. Since you have 3H, where you will put the 3H? Here. Think. You need to supply 3H. Where you will put the 3H? It's here. OH, OH, OH. Okay. Why you will not put here? Because it's already double bond. It will be over. Okay. So that's why OH negative, OH negative, OH negative. Then oxygen, 6 electrons in the outermost layer. So 1, 2, 3, 4. There are 4 electrons unshared for oxygen. Okay. So you need to emphasize if your topic is polarity and non-polarity. And you don't have to emphasize if your topic is not polarity and non-polarity. You get the point. If you try to react with another chemicals, at the time you will be focused more on the electrons you want to share. You get the point. So it depends on the specific context where you are hooked to, especially in your discussion. You get the point. But sometimes when you discuss this thing also that you need to apply everything. You get the point? Ganon. Diba? Thank you so much for watching mga palangga. I hope you like it. So, you can share it to anybody else my video as usual. Okay. Thank you so much. God bless. Bye-bye everybody. See you later. Kakaloka. Polyatomic ang ayaw talaga na. Charos.